Hi, we're here to perform a couple of tests on a transformer to determine the losses in a transformer. We have two different types of tests that we're going to do. One is an open circuit test, the other is a short circuit test. So the first one that I'm going to perform is an open circuit test on the transformer. I'll step you through the process of that. Before I do that, let's take a look at the material necessary to do this. I have a transformer, a 1 kVA, 120/240 to 240/480 single phase transformer. I have a watt meter. I have a multimeter that I'm going to use for voltage measurements. I have a variable AC supply, or a variac, and I have a clamp-on ammeter, as well as various leads. That's what's necessary to do the entire test. So at this point in time, I have it already connected, and what I'm going to do is apply a voltage to it and see what's actually going to happen. My transformer is connected in parallel on the primary side for my low voltage windings. The reason I'm doing that is because I have 120 volts available in the lab, so I connected my primary for 120 volts, the appropriate voltage supply. My secondary, I chose to select a parallel connection on my secondary, so the secondary is rated for 240 volts. I can choose that, I can change that around if I like to, but that's just what I chose for the test. So I have 120 volt rated primary and a 240 volt rated secondary. So the first step in doing the open circuit test is to apply a voltage to the primary to see what kind of power consumption I will have. And we're going to determine whether this is a core loss test or a copper loss test very quickly. So what I'm going to do is apply this voltage. And what I'm looking to see on these meters is what kind of power consumption will I see and what kind of voltage can I take it up to. Remember, it's rated for 120 volts. So you can see on my voltmeter, the voltage is climbing as I turn up the variac. So I have now applied 120 volts to this transformer primary, and it's rated for 120 volts. I have a power consumption of 23 watts here. Now the question is this a core loss test or a copper loss test? Well, I'm applying rated voltage to the primary. That would tell me that I should get rated excitation. But how much current have I got? Remember, current and copper loss is I squared R. So what I'm going to do is measure the current that's going into this transformer. And that current is about 1 amp. And that 1 amp, we need to consider, what is this transformer rated for? There's only 1 amp flowing right now. So if there's only 1 amp flowing, well, my primary happens to be rated for 8.3 amps. And where that comes from is it's a 1 kVA transformer that is connected for 120 volts. 1 kVA divided by 120 volts is equal to 8.3 amps. So my primary rated current is 8.3. I'm only drawing 1. It's a very small value of current flowing. So is there a little bit of power loss there of I squared R, of copper loss? Yes, there is, but it's very small and it's insignificant to the test. So what is the vast majority of power consumption occurring here? It's in the core. So your open circuit test is a core loss test. So while I have this all connected, I'm going to continue on with the second test to determine power loss within a transformer. That second test is a short circuit test. So all I'm going to do is turn off my power supply, and I'm going to, like the test would imply, short out my secondary. So I've just used a conductor to short the secondary out, and I'm using an ammeter to determine what the value of current is going to be. The question is going to be asked again, what current should I take this piece of equipment up to? And it's rated for 1 kVA. My secondary is rated for 240 volts based on the connection that I have. So 1 kVA and 240 volts would give me a current of 4.17 amps. So if it's 4.17 amps, that's what I'm going to take this meter up to. The question is going to be asked here though, what voltage should I apply to the primary? And the voltage I applied to the primary in an open circuit was the rated value, 120 volts to 120 volt winding. If I apply 120 volts to this now, I have a short circuit on my secondary. I will have 240 volts induced into the secondary. It will simply be a short circuit. All I'm going to do is blow the fuses. So it's going to be a very small value of voltage, and you'll see that when I turn it on and I apply the voltage to it. So what I'm going to do is turn the variac on, we'll start to apply voltage to this, and we'll get up to rated current on my ammeter. And I haven't moved this a whole bunch, and we're already climbing like crazy. So 4.17 is the rated current of the secondary of this transformer. I've got my ammeter here at about 4.2. Pretty tough to get it to sit right on there. So it's close to 4.2 amps. Under those conditions, you can see the voltage is only about 5.8 volts applied to that primary. Remember, it's rated for 120. So I've just applied 5.8 volts to 120 volt winding to get rated current flowing in my secondary. And it's consuming 52 watts of power. What is this test good for then? Well, if the open circuit test was good for core loss, it would make sense that the short circuit is good for copper. Well, I have current flowing in a winding. I therefore have I squared R. What about the primary winding? Again, I have a bunch of current there. You're going to have I squared R. So it appears that I have lots of power loss in my primary and secondary windings, but I'm only applying 5.8 volts to 120 volt winding here. What's my core excitation? It is very, very minimal. So is there a small component of power loss here due to core excitation? Sure there is, but it's very small. And because of that, we can ignore the amount of power loss due to core. The majority in this test is due to a copper loss condition. And when I take these two tests and I put them together, I add the core loss that I saw as well as the copper loss that I saw, and that put together gives you a total loss within the transformer that is used to determine efficiency. Those are the two tests that we use to determine losses and efficiency in a transformer.